I'm Josh. I'm the youth program manager here at Urban Workshop.
My name is Truman, and I'm a teacher, and this is my boss.
Today we're going to be talking about the Level 2 engine power mechanics class. So we're going to be disassembling and reassembling this and talking through how and why to do it, how to stay safe when you do, and how to get everything back together correctly. So just like most classes, we'd like to start with a safety lesson. So you want to take the safety away?
Here at the Urban Workshop, we really stress safety, and everyone who walks into the shop environment will be given a set of safety glasses. You're not going to see us with those today because we've got our own set of glasses, but we really stress that anything we're working on, we actually stress making sure safety is very important, and the use of tools becomes also part of our safety issues.
Definitely. So particularly when working with engines, we're working with an engine that hasn't been started recently. Some of the oil and gas that would usually be on the inside of the engine is not going to be in this. We don't have to take quite as many precautions as we would if we were working with a typical engine, but I'm going to walk you through as we are. So engines, as the cylinder and piston, as the pistons go up and down, heat up. So you wouldn't want to take apart an engine.
That was just been
recently
been used.
Yeah, no, you don't want to do that. That's a bad idea.
And again, to confirm, this is an engine that's clean. It's a brand new motor. There's no fluids in this thing. Otherwise, you'd have to take precautions of draining the fluids and getting the gas into a container, a safe container, taking it back to probably a gas station, as well as the oils, removing those and taking those to a gas station as well.
Another thing you're going to be particularly aware of in this class is this engine's pretty heavy, and it's sitting at a table height that's also it's fairly high. So we want to make sure that we've got a stable workspace, and that when we're putting a lot of pressure or torque on some of these bolts, that we don't knock that engine off and smash our toes, because this would definitely break some toes.
And we've also added to our list of tools a clamp that we would clamp the motor, the base of the motor down to the table itself when we start actually torquing, and we get later on in the project. So.
Yep. So as with most classes here at Urban Workshop, one of the places that we really like to start is what we call knolling, and that is laying out the tools and materials you're going to be working with in an organized fashion. One of our sayings is that an organized workspace is a safe workspace. So if you've got your tools all over the place, you're constantly going to be reaching for one tool and then a separate tool. You're going to have a hard time getting what you actually need to disassemble the engine, but you might also be a little bit less safe because so many different moving parts are moving around. Maybe you got a part jammed underneath your motor, something like that. So first thing you're going to want to do is take a minute to pull out the tools you're likely to actually need for this project, which we'll go through step by step here in just a second, and then to organize them in a nice fashion in front of you, what we call knolling. So which tools are we using for this project?
First thing you want to do when you're picking out your tools, as Josh mentioned, lay them out, but also you have to recognize, are you going to be using American Standard tools, things like 5/16 or 1/4 inch, or metric, like 8 millimeters and 10 millimeters. This engine specifically is a metric-based motor, and so we've laid out 8 millimeter, 10 millimeter, 12, and 14 millimeter wrenches to use on this. If you try and use the American Standard on a metric motor, what you'll do is end up stripping the nut itself, okay, or the bolt. So you got to make sure that when you put the bolt and the socket together, that they're actually going to be a good fit. You don't want to round these off, and it'll ruin your bolt. It'll also ruin your tools as well.
You're still going to make that mistake. I've rounded off the bolt completely, and then had a horrible time trying to undo that bolt or drill it out or worse. So yes. We do our best to caution you. Try not to do it. You'll probably make those mistakes in the future, but just always know, just as Truman was saying here, that if you're not sure if it's metric or standard, and oftentimes you aren't, there's no real indicator on the bolt, just insert the socket and wiggle it back and forth with your fingers, and then grab the equivalent, either metric or standard, and wiggle that. And the one that wiggles less inside that bolt is the tighter fit and the one you actually want to be using.
Well, and the one tool you don't want to use is this one, okay? This is an adjustable wrench, but the problem is it's not that accurate and precise, and this is the kind of tool that will literally actually pull the round off the top of your bolt, okay? So if you use this one, it's just not going to be as accurate. So we highly recommend, and we specify here using the socket set in our project.
A couple more things that you may need. It's always nice to have a Phillips head screwdriver. I can see a couple Phillips head screws on this. Probably also not a bad idea to grab a flathead screwdriver. We didn't pull one out for this project because we don't actually need it, but having one handy is always a good idea at the beginning of a project. Something else quite useful, especially when you're working inside of compartments that are hard to reach or places that are sometimes difficult to get to, is this is an extendable magnet. And this is helpful for when you drop a bolt down in some place that it's difficult to get it. You can stick this magnet down in there, grab the bolt or nut, and pull it from out from the spot that it got jammed up in. So very useful to have around. It's not useful until it is.
Yes.
And maybe you'll have to stop your project one day because you didn't have a magnet to pull a bolt out.
Very smart.
And I guess last but not least, some combination wrenches. And these are pretty useful. It's less likely when you use a combination wrench that you're gonna strip the bolt that you're trying to pull off. Socket wrenches. So the thing about socket wrenches is sometimes you go to put it on the head of a say a nut or a bolt, and you undo it, and mine keeps falling off here. You don't actually get a tight fit. It wiggles around a little bit, and all of that play on the bolt makes it more likely that when you put torque on this wrench right here, that it strips the edge of the bolt that you're working with, or the nut. So these are useful to have around, also for tight spaces or places that are sometimes more difficult to get with a different tool. And this is a full set of metric open-ended wrenches. A lot of different names for these tools. Yeah, I think those are the tools we need. Oh,
Yeah, very good.
Oh, and one more. What's this?
This is actually a wrench, the spark plug wrench. I'm not sure we're going to start with the spark plug or start pulling off the top first before we get to the spark plug, but you'll have to have the spark plug wrench. The point being here is you really want to make sure you've got all your tools strategized, like this is all tools I'm going to need, and that way it doesn't stop your progress in your project.
So I do think the spark plug is a good place to start.
You want to do that?
And the reason I think the spark plug is a great place to start when you're actually disassembling the engine is because the last thing that you want to happen is, and this goes back to the safety lesson that we started with, the last thing you want to happen is for this engine for some reason to start up as you're working on it, and the components to start moving. You'll lose your finger, you'll get cut, you really hurt yourself, something like that. So we know for sure if we pull the spark plug out of the engine head,
Yes.
it's not going to start up.
Right, we've taken the wiring off, okay, and the way to do that is this is the spark plug wrench. It fits nicely over the top, and it's a simple leverage.
Remember lefty loosey,
Yep.
righty tighty.
And with the spark plug, you'll notice that there's an electrode inside this, and basically that's where the spark is. That's why I call it a spark plug. And that ultimately, that spark there is what ignites the gas and fuel mixture which starts the vehicle. So as Josh said, once you remove this, you're assured that there's no problem with anything going wrong.
And this is probably a really good point too. Now that we've taken off the first component, we said it's important to stay organized with your tools before you start, but it's also extremely important that you maintain some kind of order as you disassemble things. Because although this engine isn't terribly complicated, if we pulled all the nuts and bolts and pieces off of it, it'd be very challenging for us to go back and put it all together unless we had some kind of order that we did things.
Right.
So each time you remove a component, it's an excellent time to ask yourself, where's the best place for this to live? And how am I likely to find it in the future when I need to put this together? And it may not be today that you're putting it together. You might be putting that together next week. That might be a project that's lived in your garage for 6 months. And I guarantee you'll have a difficult time remembering where you put things 6 months down the line. So you kind of need to think about future you.
Especially if you're actually repairing something that's broken in the engine. It'll sit to the side till that part shows up. Here we're looking at a complete motor, so during the class project, we'll take this apart, and then put it back together again. So hopefully we won't have any missing pieces, but at least having it organized in one location keeps you well organized. So.
Yeah, and this is another piece that's really useful to talk about here. I guess it's not a tool, but it is definitely an aid. This is a magnetic base, just bowl. Mm-hmm. And you can put stuff in it, and it obviously stays. So this is if you've got a floor that's slick, if you've got places that things can just roll around. If you've got a couple of these little magnetic plates, you can be pretty sure you're at least not losing things. It's maybe not perfectly organized. There's other ways to go about that, but you know that it's at least going to stay inside of this. So we like to use this little magnetic cup.
So we like to start with the air cleaner. Does that make sense?
Sure.
Let's start with the air cleaner first. This is the
point out, yep.
air cleaner up here on top, okay? And the air cleaner basically will work. This part comes off.
So, yeah.
Oh, this way, okay? It's top of the air cleaner, okay? This is the air cleaner itself, okay? This is the pad. If this were a motor that had been used, obviously this would be a different color. You can either clean these out or buy a new one of these, okay? And then removing the air cleaner is, we're back to using our Phillips screwdriver. Okay. This way. Oh, there we go. So we got the inside undone. Oh, keep it this way. Let's see. The smaller one, the one that really stays well attached, we're going to go with the 8mm socket. Oop, we'll go with 10mm socket. I'm also using an extension. Once you actually break loose a nut or bolt, it's actually a pretty good habit just to use this to end up using it to screw that part off. Okay. There we go. Comes this way. The air tube comes off this way. And again, so we have the complete part. Now, once you remove the air cleaner base, okay, you can actually then, to keep things organized, put it back together. We can put the nut we took out, the screw that goes back in here, back with this, put the air cleaner in. This will snap back together. Like this. And then obviously keep that together. We can keep the nuts in here for a time being, because I think they'll keep them there.
Or one alternative to this. So these will go nowhere, but the easiest way I find to know how to find these at all times, and specifically where they came from, is you've got right here. You've got a couple loose parts, and we may end up taking this off later. That's fine. We'll just take these off, take the component off, and then once again screw these back on if we have the area to do it. To me, this is the preferred way to do it, so that you always know exactly where things are going. But of course, if you're taking a lot of components off, that may not be ideal for you. One other quick thing is the air filter itself. What's it used for? Why do we need it?
Cleans the air. Basically, the internal combustion motor works off a mixture of fuel, gasoline, and air. And obviously, you don't want any kind of dirty particulates getting into your engine, which wears the engine down. Okay, so basically, the air filter filters out any contaminants coming in the air.
Yeah, and you can imagine any of those little dirt particles that come in when metal rubs against metal. You need oil inside your engine. So if you have little dirt particles wedging themselves between the two metal components, then you get etching marks and eventually blown motors,
right,
broken components.
And the best way to see this is if you actually pull a filter off an engine that's being used, you'll see that they're actually black and dark and really kind of dirty. So there's a lot of things they do pick up.
Totally.
Really important.
Yeah, very important.
The other end of the engine is the exhaust. There you go. Now to take off this is the exhaust cover. Obviously they pull the cover on here, and it obviously there's a diagram that says hot. So usually on most engines you will see warning signs here and there, like even on the top of the gas engine as well, reminding you that this is something you need to respect. So we have the top of the the exhaust part here. The exhaust itself, okay, is bolted to the exhaust side of the engine or the head itself. So when you have the gasoline and air mixture coming in through the intake where the carburetor is, and then when the exhaust coming out the exhaust, which is why it's really hot. Now my socket wrench doesn't necessarily fit on there too well, so I'm going to go to the let's see, 12 millimeter. Oop, 12 millimeter doesn't work. And again, sometimes it is trial. 14 millimeter. Okay, that didn't work. So we'll go between 12 and 14 is what? 13, right? So we'll use a 13 millimeter wrench. Yeah, that actually works. And you'll also notice with the wrenches, open end wrench, it has a little bit of an angle to it. The idea is you can put your hand here, and this is the surface, and you can pull this way and not rack your knuckles on the engine itself. The open end part has a little little angle to it in such a way that you could actually flip this around. So getting in tight spots, you can move it this way, or you can flip it around and move it like this. So it gives you a little bit more area to actually work the nuts. And then going back to this, again, part of our procedure is we want to lose anything. So we'll just put these back on where they belong for assembly later.
And the same could apply. You may have noticed we didn't actually put these back in. You could absolutely put these here too. Now the only downside to doing something like this, where they live in here, is if you go to pick up this piece later and you kind of tilt it to the side, these aren't secured by anything.
Right.
So this is one instance where I'd say it's probably a better idea to put them here than to let them live here.
Okay, basically we have the serious part of the engine exposed, and now we're going to take off the carburetor here, okay? And what you'll see the actual throttle, okay, and the air inlet or choke, which you'll have to decongest. This is the choke, which actually adjusts how much air is let in at the time that you need to first start the motor. Most engines that are cold need a little extra air. If you know from your science, you actually add more oxygen to a gas mixture, it actually runs hotter. Okay, so you actually can heat this up pretty quickly. The engine will heat up pretty quick when you have the choke open with more oxygen exposed to the gas, and then you can close this down as the engine heats up itself, because the engine then actually creates its own heat and you don't need as much oxygen. And this part is actually on the same design as the filter. And once you dislocate, again, the gas fuel mixture, and again, I want to stress this engine it's a brand new motor. There's no gas that's ever run through this. But obviously, if this was an engine you had taken off your lawnmower, you'd want to have some way to capture the gas that's going to be left in this, okay? Because there will be gas in this. On the bottom, this is the actual bowl, which is a reserve of gasoline. So you want to be very careful if you're working with an engine that's actually being used as you would be at the on a lawnmower. Now I'm going to put these back in here.
Yeah, and you can probably see the choke open versus the choke closed is right in here. It's a pretty simple mechanism. It's just a flap that allows more space and there's more area for oxygen to flow through this flap when it's completely open versus closed like this. That's called a butterfly valve, I believe. So when that flap is completely open, just as Truman said, you've got more oxygen coming in, you've got a hotter mixture, and that's what you'd want when you start your engine.
Right.
It's a little bit harder to get it started than it is to keep it running.
And then this side here, this is the throttle. This is the part that opens up, that actually regulates the air and fuel mixture. So once you've got it started with the choke, closed it down, then this is the part that lets it go zoom zoom. It's my old Mazda days.
Perfect.
Okay. What really makes the engine start is this is a magneto ignition system. Magneto means basically you have to have a spark, something that sparks the spark plug, and this is why when you pull this, okay, that actually is sparking the spark plug, electrical system, makes it come to life. The spark is what actually ignites the gas fuel mixture. So when you first do this, you're turning it over, and that magneto is basically then sparking the combustion.
It's charging up the spark plug, basically. It's sending enough energy into this for there to be a spark that jumps across the two.
Yeah. Now this has been taken apart a few times, so I've got an opportunity here just to do a hand tighten on this. There we go.
Also, as a general idea when you're working on things, especially larger engine components, you can do this on your own. You can pull all these components off on your own. but a lot of times it takes a little bit of imagination for, like, as we take this component off, it's going to fall to the ground. And so if you're working on an engine, especially inside of a car, and you go to take a component off, you need to be aware if you're taking that last bolt off. Because if that component's going to fall off, it's probably a good idea to figure out where it's going to fall and make sure it doesn't fall on you, make sure it doesn't break, make sure it doesn't hurt you, something like that. So a good idea to work in pairs.
Yeah, well, it's always good to work with a friend, but also I don't want to work with flip-flops. Have that stuff fall on your toes. So I hear at the workshop, you will not be allowed into the workshop unless you're wearing
Closed-toed shoes.
Closed.
I don't know. It's
closed shoes.
Closed-toed.
A complete set of fashion wear. What you also notice here, there's fans. There's fans on this which is interesting. It kind of brings up, why are there fans in here? Because this is an air-cooled motor. So a little of the dynamics of it, you have fins. There's no water running through this as it would be in your parents' automobile. But this fan, what it does is when this gets hot, these fans dissipate the heat. So having air wrapped around these little fans actually dissipates the heat, so it keeps it from actually overheating. But what this engine has, which is neat, is it actually has a fan system in here. So when you started this thing is turning, you can actually see the fan blades in here, which actually creates a little bit of air flow over the engine, which keeps it from overheating. Now, as far as taking this shroud off,
like about you have the 8mm. 8mm socket wrench, again by hand. It'll almost never be this easy to remove. It shouldn't be this easy to remove the bolts from yours. If it is this easy, then you're lucky it didn't just break apart. Yeah.
Yeah, but
because these have been taken apart and put back together multiple times, and that's their only purpose, the bolts aren't always completely tight.
Yeah. Here's our shroud. It's also connected to the negative ground on this. In one of our classes, you'll talk about electrical systems. And there, we've got the shroud and the pull mechanism. Okay. So for sake of time, we don't take the gas tank off. We don't need to. And then do you want to let's start on top of the motor?
Yeah, I think let's remove the front of this. We've got some dangling components. Just make sure we're out here. We're going to go ahead and remove the valve cover. Again, it looks like an 8mm. That's my guess.
I think we're all.
That's a 10. You have the 8mm going here. Let's see. Yep. And once again, our bolts are looser, so I'm not actually using the socket wrench. I'm instead just doing this by hand.
We're also getting lucky because the nuts or the bolts we're taking off actually are about the same thickness and diameter, and we can actually just put those in one clump.
And now this is the point where we've got only one left, and it's just barely on there, so I'm supporting this piece with my hand before I completely remove this. Not because this is a light component. I'm not so worried about this component specifically in terms of safety, but I don't want to damage these. I don't want to drop these on the table and suddenly make a $5 or $10 repair turn into something where it's a lot more.
And you can see we're actually organized our workspace and stuff to be enough space that we know we can take the engine apart and lay it out like this. This would be the way you would lay it out in our classroom. You'd have a table this size, and each student would have the ability to actually lay this part out as you see here.
Yeah.
Okay. And it's called a valve cover simply because that's the top of the valves. Okay. This is actually the connecting rods are in here, and these are the rocker arms through here, and these is what move the valves up and down based on the cam. And we'll get into that when we take the head off.
Perfect.
So do that.
Let's take it off.
Do that.
Yep.
Okay. Now, as we're getting to taking the heads off, I see that some other parts that are actually in the way of my head bolts. These head bolts are much stronger than the other bolts. They're bigger, okay? But the problem is I need to take off the throttle linkage, this part here, okay, to get to this one bolt, which does happen. We got to rethink the process of how you're taking things apart sometimes.
Looks like it's attached, yep.
There you go.
So I noticed you used a little trick there. So we're going to pull this whole component off. Now one of the things that you can do, if you pass me the other side of this, one of the things that you can do is you can use the lever to completely take your part off, or you can use your fingers once you've loosened it a little bit and just move this part of it by hand. So you're going to get to use, when you're using these tools, even though this is the traditional handle right here, you may often find yourself using them in a slightly different way, and that's fine. Sometimes a different way of using your tools a little bit more effective for a different purpose, just like that.
Mm-hmm. Again, this is the throttle mechanism, and we have the spring here. As you start to take the throttle linkage off, we got springs exposed, and it starts to get a little complicated. If you look up this motor, again, the motor is on the side of the casing here. It's a 212 cc motor, which means that's the difference between the stroke and the bore of the cylinder. So that's a 212 cc motor, or cubic centimeters. Okay, you look this up and you find the motor online. Along with the specification sheet, you'll also see a diagram and a parts diagram of all these little bits and pieces. So it's always worthwhile, maybe at this point, you go back just to document what you're doing, go online to the computer and actually print out the actual specification sheet. But for us, we've taken this apart enough times, we can get through this. So, this here. Also, take a look at your tools. It's a little bit of a mess. Take a second, just sort of put things back in some order, because you don't want to keep, just keep things nice and orderly, okay? Then, now that opens us up to going back to the head.
Once again, it's a little bit easier than the entire mechanism of the socket wrench.
Okay, that should, let's see, there we go. Now usually there's a gasket. There we go. And of course, all our connecting rods fell out, but there's always a gasket between the head and the block of the motor. We'll take the connecting rods out, these over here.
And basically the general idea with gaskets is anytime you have especially airtight or liquid tight metal touching metal, you're going to have some sort of gasket, because metal doesn't make a tight seal to another piece of metal. Mm-hmm. So you need some buffer between those two things to actually seal it off completely. So you should be looking, when metal's connected to metal and you know air or fluid is running through it, you should be looking for all kinds of different sizes and shapes of little plastic gaskets.
Yeah, and you look inside here, and these are the valves. And obviously one's the exhaust valve, and this is the exhaust. This is intake. This is the intake. This is the carburetor side. So obviously when the engine is looking for gasoline, this valve opens this way, and that's when the gas and air mixture flow in. And then after it's gone through its combustion cycle, and then the exhaust cycle, and then obviously this valve opens up, and that's your exhaust port through this way. So these actually work back and forth to enable you to intake as well as exhaust.
And we'll go more through that as soon as we have one more component pulled off of this engine so you can see inside of it. We'll go completely through that 4-stroke engine process.
Okay. So you expose the top of the piston.
Yep. You can see this is a little bit uneven. This is a point where you're going to want to take a little extra precaution, maybe have somebody else with you. Hold down your engine so that it can't topple over onto your toe and break it.
Mm-hmm. The other thing is also a good technique is just go ahead and loosen up all the, when you got a circular pattern of bolts like this, it's actually a good idea just to sort of break each one loose like this. This is almost the same way we'll actually put it on. You don't just tighten one down all the way. You actually go into a pattern of tightening them slowly. Yeah. So now these are actually
Now, if you're not careful, as we said at the beginning of this lecture, the inside of the engine cylinder, we need oil between metal components so that they slide past one another without much friction to improve efficiency. So when you go to take something like this off inside of a sealed engine compartment, you're likely to see oil spilling out of the edge of it. So if you're inside of a workspace that you're trying to keep clean, make sure that you know how that oil is going to drain out. And in the bottom of our engine, again, we know that there's no oil inside of this engine already, but at the bottom of our engine are actually 2 bolts. And if you were to remove both of these right here or one of these right here, most of the oil will drain out of that engine before you actually take this part off. Mm-hmm. So it's generally a good idea to consult the manual as well to make sure that you know what you're taking off and what you're likely to find inside of it before you have a mess all over your floor.
Yeah, great point. Also research a little bit where you're going to put the oil when you've got it done. If you put it into a container, you might want to check your local gas station because they're actually a pretty good source of illuminating the oil, and or a parts store if you're going to do something like on a working motor.
Yeah.
This part steps off here. What you can also see, which is interesting here, this is the inside of the casing, okay, the block casing, and you can see that this is the mechanism for or measuring the amount of oil you put in it. So you can see that the oil level, if this was full of oil, would actually be about this much of the actual engine itself. This is a bearing here, okay, and you can see that it's actually a roller bearing. You've got little ball bearings in there that keep that from actually, they keep the crank actually in place, okay.
Excellent. So I think it's a good time to talk about the 4-stroke engine process. How does an engine actually work to make our cars move, things like that? So what is the 4-stroke engine process?
Basically what happens is you've got the magneto, okay, and on this side of the motor, you can see, hopefully in here you can see where the piston is, okay. What you've done is you've grabbed this with the cord. This actually turns magneto, which actually gives the spark. So you've got the spark plug here in place. It sits above the engine like this. It sits above the piston, I should say. So if we start with what's called top dead center of the motor, when the engine turns around, you've actually done this with the cord to pull this motor, it goes down, okay? At this point, what that's called, that's the intake part of the stroke, okay? And that actually creates a vacuum. So the piston itself is actually pulling in the air-fuel mixture. That's why it's called an internal combustion motor. It's actually pulling in the mixture. When it comes down, it's actually pulled in the air-fuel mixture. It comes back up. This is called the compression stroke, this way. At top dead center on compression stroke, or near to it, you're going to get a spark. And that spark then forces that and expands all the gases. You get really an explosion inside the cylinder head, which pushes this piston down. That's where you get the real power or torque, okay? Then as it comes back down, it spins back around up, pushes all that exhaust material out of the engine, and that goes out the exhaust port, and that's your 4th stroke. Again, a 4-stroke motor.
So in the 1st stroke, we've got the fuel and air mixture being pulled into the engine. On the 2nd stroke, you actually need to compress that mixture so that it ignites efficiently. So in the 2nd stroke, we've got the piston head coming back up and compressing all of that. And just before it reaches the very top, a little spark in our spark plug ignites that entire mixture so that it completes the top portion of its movement, and then it's forced back down. And then that final stroke is, now we've got waste material, which in our case will be mainly carbon dioxide and water. So we'll have that waste material that's kind of pushed out of the side of that exhaust manifold that we took out earlier in the lesson.
Okay.
So,
and as we mentioned in the start of our video, safety is really important. The machining of these engines is not designed for your fingers to be in here, quite frankly. So everything's very sharp, and things can cut you. You can get your finger caught in the gearing. This is the cam. Okay. This is actually a cam lobe. This is actually what moves. This goes around this way, and that actually what moves the valves up and down inside the cylinder. Okay. But like I said, everything here is really sharp in terms of how it's machined. Okay. So you can't cut yourself.
and especially if you're working in pairs, and this is a good point, is if you're working in pairs and you've still got the pull cord assembly in, your partner who you're working with may be moving these internal components as you have your hand inside of them. So it's very important that you communicate with one another, especially when you're putting your fingers inside of something like this, so that something doesn't move and smush your hand or break it or worse.
Yeah, this is the crank. And you've got the rod, which is the connecting rod to the piston. And this is as far as we'll take the project. Generally, your class structures you have here, we have about 3 hours. We want you to get the internal, the whole, basically the presence of what the engine is, how it functions, how it works. And at this point, would have stopped our project and just talked about it some more, so everyone understood why this thing turns around the way it does, how it works. You can see here, as you can see with the piston moving up and down, that the piston and the connecting rod here to the crank is right here. Here's the connecting rod, and then that moves in such a way that that is going back and forth. But you see it's off center, so it actually goes back and forth.
There you have it.
There.
So now the part of reassembly. So this again, you may have gotten to this stage and not quite remembered the order that you've taken things off. So anybody can take an engine apart. But the hard part about taking an engine apart and studying it and starting to understand the internal mechanics is actually putting it back together.
Okay.
So we're going to go back through quickly.
Now, one thing you'll notice, I pulled this part out, and there's also, anytime this is basically the cam, okay, and this is the gearing, and you'd always have a mark of some kind. You see a little mark here. Like, how do you know how to put it back in place so that it actually is going to work properly, okay? And again, the specifications would show you that on the parts here, there's usually a little marking, very small little marking. There's a little dot. Like here's a little dot on this gear, on the little gear, and there's a dot on the big gear. So you match the dots. Okay, make sure these are called lifters. Okay, these are the parts that basically bounce up and down. Well, here, hold that.
Yep.
So those parts bounce up and down. Okay, as they do this, the connecting rod's up here. This pushes down on the rockers, and on the valve. So as this part does this, this pushes this up and pushes this up and down this way. Okay, but we got to make sure those are actually in place and the proper amount and the gearing. So we'll make sure that when we put this back in, put the lifter back in. There we go. So that's the timing. Basically, these are the timing gears, and that dot on the big gear matches the dot on the little gear, and we know that if we put this all back together and fire it up, that the valves would actually work in sync. Okay, so we've got this part in place. We can put the cover back on.
Yep.
Okay, you've got a rubber seal on this side. You got the inside, the ball bearings here, the bearing, and you got a rubber seal here. You got to be very careful of the rubber seal, that you don't hurt the rubber seal in a real motor, but obviously this is a project we're using in class.
And again, that's that same idea. You've got an engine compartment filled with fluids, and you have two pieces of metal touching against one another. They're not going to make a tight seal, so we'd have that little gasket in between them so that oil doesn't leak out of your engine. And a lot of times you can actually see, if you're looking at engines, you can find and spot little leaks, and it'll be something like a gasket in between two metal components that's worn down.
Okay. Also, if you notice, I put this on very carefully, straight on. No way would ever take a hammer to an engine or anything like that. So this part should fit and fit snugly. As we then put the, there we go.
There we go. So we've got the part on, and now anytime you're putting an array of bolts back in, you're going to want to put them in, first tighten them by hand. You'd never start with a tool to tighten the bolt in. So you're going to tighten this by hand, and you can just put them in a little bit so that if you're working with a partner or even if you're working alone, you know that it's going to stay in place as you tighten the rest of those bolts down. So we're going to quickly get these back in. And then, now they're on a little bit, so he doesn't have to worry about actually holding them. And then, what are we looking at here? 12 millimeter?
These are 10, I think.
These are 10. 10 millimeter. There we have it. And we will hand tighten these first. And I include this in hand tightening. You can get a little bit of extra force with these, but you're not going to over tighten. So you're going to get them all down so that they're flush. And we're going to do it, ideally, one on the top left, one on the bottom right, in kind of diagonal pattern. So that instead of having the likelihood that our two pieces come together and then get a little bit off, it's much more likely that they make that flush, nice contact in the end. And now this is a little tricky. You want to not over tighten. You may have to change your socket wrench to go the other way here. You want to not over tighten, but you do want to tighten each bolt. Once again, going in our pattern here, where you go one bolt and then a diagonal bolt and so on. And we do not need to over tighten. There we have it.
Especially for the next guy. Okay, so now it takes us to, okay, back to the head now. Assembly of the head. We've got, what we're going to do, got the gasket, and usually there's a part here that actually keeps the alignment. So you got to make sure that this goes on. It only goes on one way.
And you can usually tell by looking, even from the little etching in the metal, what's been touching other metal components and what's been touching a gasket. So the pattern and the actual look of the metal are both indicators.
Now what we're going to do, we can actually take these off. That one's kind of loose. Don't want to forget the, I think we'll put those in afterwards. Okay, so put the head back on. Okay, there we go. Head bolt. And again, when you grab these things, just make sure that they're the same size. Okay, so yes, we all have head bolts of the same size, so the same length, I should say.
Again, start with a finger tight and then move on to using the tools and actually torquing things down later. It makes it much less likely that you're going to strip your bolts and ruin things as you go.
Again, usually in the specification sheet, it'll show you how to go back and forth diagonally when you're actually doing the final torquing on these. Point being, you never actually tighten down one bolt at a time. Okay. Now to put we got to put the connecting rods in. What I want to show you is that these are the rocker arms. Put the connecting rod down on top of what is the lifter, and this is the rocker, goes on top of this. And it's called a rocker because it actually rocks back and forth. Goes on top here. And we'll just simply put this part down. Now, if this were a 350 motor, 350 Chevy motor would actually give you a specification for torque, and you'd actually have a little device for actually fitting underneath the rocker and the valve to see, or the spring, in order to see how much clearance you would take. But I think on this motor, this works. Yeah, 14-inch open end.
You got a hell of
Yep. This is where the 14mm open end works, because I can just break these loose. Put the other push rod in. Make sure it seats well on top of the lifter. Goes in place here. And then what you've got, so this bolts it down. And then on top of that, these are the lock nuts. So you'd actually bolt it to whatever the specifications have you torque it, and then you put these on top, and these actually lock down on top of that other bolt to make sure it doesn't loosen up during operation.
Okay. Yeah. Let's put the assembly right here back on.
Okay. At this time, it might be a good time, since we're looking at the top of the spark plug. Put the spark plug back in.
Let's do it.
This will keep any nuts and bolts falling down top of the cylinder. Yeah, you put the valve cover on now. Okay, now we're going to keep with our assembly and the side cover here that holds the pulley mechanism. And as you can see, I'm kind of searching where this goes.
Turn around.
Oh, here we go. This goes this way.
Yep.
There we go. Again, just take your time. Don't have to force anything. There we go.
Some of these are tricky to get to. Full extension piece here. Move it my way just a bit.
Well, there you go. Almost time for the magnet.
Well, yeah.
Oh, show the
There you
magnet.
have it.
Magnet in process. There we go.
There you go.
Excellent technique. And we can't stress enough that everything should be, again, everything will have a little bit of oil on it, so it should go hand tightened. The worst mistake you're going to make now is if you actually force these things into place and destroy your threads.
Be gentle, be gentle. This is the hardest one to put back in. There we go. Yeah, so by doing this by hand, we know, yeah, we're not messing our bolts up. Or our engine block.
Yeah, or the engine block. Yeah, you don't want to get in.
Even worse.
To rethread your engine block. That gets to be messy. Okay. Again, as we stressed before, just a little bit of hand tightening in a circular fashion, going diagonal. There we go. Again, this should only go in one way. Just see, I think that should work because the logo should be up.
We only have 2 bolts holding this assembly on, whereas typically we'd have 3.
Yep.
And that's probably because...
You know what? Might have an extra one.
Do we have an extra bolt?
I think let's try this one here.
Let's see.
Let's go for it.
That's why it's important to keep track of what you have. There we go. You are correct. And then do the final tighten. Okay, put the carburetor back on.
Again, as we took it off, the throttle mechanism, butterfly, is on the engine side. And there's nothing that goes any film there, right?
Nope.
That's pretty much it. Okay, tubes. This is the gas line here.
Yeah. So you can press that on. You can see too, what we have next to the gas line is a clip. And that clip is going to go over the assembly here and down. You may consider a pair of pliers.
There we
Like
go.
that. And we have the cover on top of that.
There we go. Got the choke. There we go. So you make sure your choke is clear here, your throttle, all these mechanisms on the side. Okay. I think I hit a screw in here. There you go. Sneak in here.
These look like 10 millimeter, and they are. There we go.
Good. Okay. Got it there, cleaner. There we go. Again, this is the exhaust side port. This is the exhaust, actually called expansion chambers in some ways, but also a muffler, keeps the noise down.
It's like a 12 millimeter. No?
Weird, I think I
That's
used
the weird
that.
size.
Yeah.
Okay, so I'll hand tighten this down, both sides as evenly as I can. Yeah, that's the weird size. I'm gonna go back and forth. Oh, that one doesn't fit very well, does it? Those are funny.
Yeah, I was surprised at 13 millimeters. I've not worked on too many engines that had 13 millimeter, but you know, there's always a surprise someplace.
And this. There we go.
Okay.
There we go.
Color assembly. There we go.
You start to feel tension early on. You're putting this screw in. Stop. Reverse the screw, back it out,
Yeah, take your time. You're not. You should not be in a hurry.
and do it again. There you have it.
There. So that's it. Nothing left over. Cleaned out the dish.
Yeah, always a bad sign if
Always
you have a
yeah.
leftover
Cleaned
nut
out
or a
the
bolt
dish.
in the dish.
Good sign.
So that's the engine assembly and disassembly. If you'd like to do this more at home, we purchased our lawnmower engine at Harbor Freight.
You can also get them online, Amazon, or if you do decide to take apart a motor that you've got that's been used, really got to make sure the safety is important, and you find a location for the used gasoline and oil. Very, very important, because you just can't dump that stuff out, and you've got to find a place that'll actually take it in a safe and recyclable situation.
So thanks for joining us, and we hope you had fun. Thank you.